Project 2, Stat 355. The first thing you'll notice is that this is the same data set that we used in Project 1. So when you open it up, it'll look exactly the same as when you first opened up the data set for Project 1. Going to the first question, what we'll be doing here is a hypothesis test to determine if the probability that this type of cable will break under a load of 10 kilonewtons is more than 30%. So first, when we're stating our null and alternative hypothesis, you should write up your project very neatly. So if we're to use Word, then we could use the equation editor. There's also, if you're comfortable using LaTeX, LaTeX might be a good option to write your project in as well. So if we're going to use the equation editor, if you type Alt and then the equal sign, that'll open the equation editor. Then if you go up here, there's all of these like point and click sort of options. So so if I were to choose this one, for example, then I could write H and then O. Okay, so that'll be the null hypothesis. That looks a lot nicer than if you were to just type. If you were to just type outside of the equation editor, if you were just type something like HO, it looks a lot nicer in the equation editor, okay? So we should use that. And then you should type up what your null hypothesis is. Is it something like greater than 0.3? Or, what is it? Type it up. And then also type up what's the alternative. Okay? So it's not greater than 0.3. You have to figure it out yourself. I didn't just give it to you. Okay, so next, to calculate the test statistic. So in order to calculate the test statistic, you're going to need to know what the estimate probability of breaking is in this population. So in order to do that, you're going to have to calculate the cable strengths. So the cable strengths, you did this in Project 1, so it should be super familiar. You remember it equals 4 times the min of the 4 wires. Okay? So drag that down for all of the wires, so you'll have 20 cable strengths. And then you'll estimate the probability of breaking. Again, you already did this in Project 1. You can use the COUNTIF function. So, and then highlight all of your cable strengths, and then count if it's less than or equal to 10. So that'll give us a count of the number that are less than or equal to 10. And then if we take that and divide it by the sample size, 20, that'll give the probability of breaking. So you calculated this in Project 1. It came out to be 0.55. So do it again here. Okay, and then to calculate the rest of the test statistic, you just need to know the equation. So it'll be you'll be using this, and then you'll be subtracting off the 0.3, and you'll be dividing it by square root of 0.3 times 0.7 divided by 20. To calculate the test statistic, type it up really nice here. So you'll write TS, so the test statistic, and then you can go up here and you can write different fractions. Okay, you'll need the radical on the bottom, so you get equation tools, and then so you'll need the square root. Okay, and just type up what it is that you calculate, say what it equals. Next, provide the p-value. So the p-value, you can calculate that in Excel, or you could use the table if you choose to use Excel. So say, for example, we were to calculate our test statistic and it's 1.96. It's not, but say, for example, it was. To calculate the p-value, you could use this function called normDist. Okay, and so you give it what the t is, and then the mean is 0. Standard deviation is 1, and it's asking, do I want it cumulative? And I do, true. Okay, so what this is basically the probability of z being less than 1.96. So that's the left tail, right, or the left side. If I was interested in the right side, if I was interested in the right tail, probability that z is greater than 1.96, I would take 1 minus that value. Okay, and then that would be my p-value. And then lastly, state our conclusion. So when we're stating a conclusion, it should say reject the null hypothesis or fail to reject the null hypothesis. And then it should say something along the lines of there is evidence to suggest that the probability of this type of cable breaking under a load of 10 is more than 30% or is less than 30%, or you could say that there's insufficient evidence to suggest that the probability that this type of cable will break under a load of 10 kilonewtons is more than 30% or less than 30%. Something along those lines. So type this up, make it look nice.